Bienvenue à bord. Today we're starting a 4-part deep dive into the kitchen's smallest machine, yeast. Part 1, the propulsion system. Yeast functions as a biological propulsion system through the metabolic process of anaerobic fermentation. In this context, the propulsion is the generation of pressure and gas that drives dough expansion in baking or creates carbonation in brewing. The fuel to yeast cells is carbohydrates. Yeast cells require energy to live and reproduce. They feed on carbohydrate sugars present in the environment, such as glucose, fructose, sucrose, or maltose in dough or wort. The engine, anaerobic metabolism, often termed as fermentation. When yeast is placed in an environment with little or no oxygen, anaerobic conditions, such as inside a dough mixture or a sealed fermentation tank, it switches to fermentation to produce energy. A process called glycolysis often occurs where yeast breaks down glucose into pyruvate, generating a form of energy for the yeast cells called adenosine triphosphate and NADH. In the absence of oxygen, the pyruvate produced is converted to acetaldehyde and then into ethanol and carbon dioxide. The biochemical equation. The propulsion. The carbon dioxide produced is a key propellant. In baking, the carbon dioxide gas is trapped by the gluten network in the dough. As the gas bubbles expand, they exert pressure, forcing the dough to rise. Aeration. In brewing, the carbon dioxide dissolves into the liquid, providing carbonation or escapes, driving the agitation needed for fermentation. There are factors that affect the propulsion efficiency. One is temperature. Yeast activity is temperature dependent. Optimum fermentation for yeast typically occurs between 20 to 30 degrees Celsius or 68 to 86 degrees Fahrenheit. Too cold slows it down, and too hot kills the cells. Oxygen availability is also to be considered. While fermentation is anaerobic, yeast needs a small amount of oxygen initially to build strong cell walls to maintain high vitality for long-term fermentation. Sugar concentration should also be noted. High concentration of sugar can act like an osmotic stressor, slowing down the propulsion rate. Therefore, in summary, yeast serves as a biological propulsion engine by acting on sugar through anaerobic fermentation, releasing carbon dioxide gas, which is a propellant, as a metabolic byproduct that creates pressure-driven expansion. Think of yeast as a biological reactor. When it heats sugar, a chemical reaction occurs, that is fermentation. The excess is a CO2 gas. In mechatronics, we use gas to create pressure, and that's exactly what's happening in your dough. These tiny CO2 bubbles are trapped by a gluten web. As the gas expands, it creates internal shift, forcing the dough to rise. It's a low-velocity vertical launch right on your counter. Without the gas engine, your bread is just a brick. Stay tuned for part 2, where we look at how yeast builds the flavor architecture. Explorons, la science, ensemble.